Now, on your screen in a second, there you go. You can see a live view of SpaceX's two-stage Falcon 9 rocket with our Dragon spacecraft at the very top. Today marks SpaceX's sixth and final mission to the space station for 2023. And in fact, this will mark the most flights Dragon has flown to the orbiting laboratory in any single year. Since taking flight in 2010, Dragon remains one of the few vehicles that can deliver significant cargo to the space station and the only vehicle that can deliver cargo from the space station. It's a fully autonomous vehicle, which means it's capable of flying itself to and from its destinations. Today, Dragon has visited the station 38 times and transported more than 300,000 pounds of cargo back and forth from the orbiting laboratory. It's also the first private spacecraft to take humans to the space station. Falcon 9 and Dragon were both designed with reflight in mind, and the vehicle hardware is built to support multiple missions with minimal refurbishment. Today's Dragon is flying for its second time and marks SpaceX's 21st reuse of the vehicle. Below Dragon is Falcon 9, which you can think of as two rockets built in one. The lower part, which is also the larger part of the rocket, is called the first stage. The first stage has 9 Merlin 1D engines, which accelerate the vehicle through the Earth's atmosphere and into various orbits in space. At the top of the first stage is the black inner stage, and above that is the Falcon 9 second stage. The two stages will separate about 2.5 minutes into flight, and then the second stage will ignite its single Merlin vacuum, or what we call the MVAC engine, which is the 10th engine on the rocket, to carry Dragon to its desired orbit. Now, like Dragon today, the Falcon 9 first stage is flying for its second time as well, and we plan to recover it back on land at Landing Zone 1, located at Cape Canaveral Space Force Station in Florida, completing the first return to launch site for a Dragon cargo mission. Now, so far, we've reflown 214 first stages, and that includes Falcon 9 and Falcon Heavy. If successful, it will mark the 243rd recovery of an orbital-class rocket.
Launching on this mission is part of NASA's first two-way laser communications relay system known as Illuma-T. After attaching to the outside of the space station, this laser communications terminal will send and receive data through NASA's LCRD satellite on orbit. Using invisible infrared light, laser communications can transmit data up to 100 times faster than traditional radio frequency systems. Illuma-T brings this capability to the International Space Station, enabling more data to be transmitted and received. And of course, more data means more discoveries. Also on this mission is the atmospheric waves experiment known as AWE. This heliophysics experiment will capture the first global observations of atmospheric gravity waves that form near the surface and impact Earth's upper atmosphere. Increasing our understanding of these waves could teach us more about Earth's atmosphere, climate, and near-Earth space weather. AWE is also part of what NASA is calling the Heliophysics Big Year, a global celebration of solar science and the sun's influence on Earth and the entire solar system. Right now, there are 7 people living and working on the space station, making up the Expedition 70 crew. This expedition began on September 27th, and the team represents several international agencies: NASA, ESA, JAXA, and Roscosmos. During their long-duration stay in low Earth orbit, they will research heart health, cancer treatments, space manufacturing techniques, and more to benefit life on and off the planet. CRS-29 is expected to dock to the space station this Saturday. That's November 11th at 5:20 a.m. And NASA astronauts Jasmine Montbelly and Laurel O'Hara will be monitoring the operation to ensure all this cargo is delivered safely.
And at T-minus 3 minutes, 22 seconds and counting, we are waiting for a call for Stage 1 liquid oxygen loading complete. This launch will take about 6,000 pounds of hardware, crew supplies, and science to the space station.
Stage 1 LOX load complete.
And there we have the call we were waiting for. Stage 1 LOX load complete. That is the liquid oxygen. One of the larger pieces of equipment that CRS-29 is carrying tonight is a technology demonstrator. It's called Illuma-T, and it'll transmit data to Earth on lasers. Those lasers can hold a lot more data than previous communications equipment, and this trial will show how that rush of data can help researchers learn a lot more about their work on the station. Dragon will be docked to the space station for about a month before returning home. At T-minus 2 minutes 25 seconds and counting, we are awaiting the checkouts of the second stage thrust vector control actuators. And this is often referred to as an engine wiggle test. This is when SpaceX moves the thrust nozzle on the second stage slightly to make sure the guidance software and hardware is ready for flight. SpaceX does the exact same test on the first stage engines just seconds before ignition.
Stage 2, LOX load complete.
And great call out there. Stage 2 LOX load is complete, which means that propellant loading is now complete on both stages of the Falcon 9. Dragon is also performing its final health checks to make sure that all the vehicle's primary systems are ready for its rendezvous with the International Space Station. You may have noticed that there's some white clouds around the vehicle there on your screen. Those clouds are normal. That is the chilled gas above the tank liquid surface for the liquid oxygen that we vent out overboard to maintain pressure in the tank as needed. And once that cold gas comes into contact with that warmer air, it creates those white clouds that you see there.
And we are at T-minus 1 minute 5 seconds and counting. Soon the Falcon 9 computers will enter startup mode.
Falcon 9 is in startup.
And there we have the call from the launch director. Falcon 9 computers have entered startup mode and the Dragon spacecraft is on internal power. Both stages are now pressurizing for launch. And
LD, go for launch.
And there we have the on-time call of the SpaceX launch director verifying we are go for launch this evening. Liftoff scheduled for 8:28 p.m. Eastern Time and 14 seconds. At launch, the International Space Station will be flying 259 miles over the Arabian Sea near the coast of Oman. We are 15 seconds to launch and counting.
15 seconds and counting. T-minus 5, 4, 3, 2, 1, ignition, liftoff.
And liftoff of CRS-29 carrying cargo, research,
Full
and a laser,
switching downrange.
and a laser communication.
Engine pressure is nominal.
A laser communications demonstrator to the International Space Station now in its 25th year of orbital operations.
Nominal power and telemetry.
At T plus 40 seconds, Falcon 9 has successfully lifted off from historic Launch Complex 39A in Florida. We are now coming up on max Q in just about 15 seconds or so. That is the
Falcon
point
9
of
is
maximum
supersonic.
aerodynamic. That's the point of maximum aerodynamic pressure that the vehicle will go through during its flight.
Max Q. Nico.
Stage separation confirmed.
Stage
Contact
1,
ignition.
boost spec startup.
Love those views on your screen. You could see stage separation with the first stage heading back to land and the MVAC engine on your screen lit up. And on your left-hand side there on your screen, you can see the first stage in its boost back burn. Some really awesome views there. On your right-hand screen is a view from the second stage looking at the MVAC engine. They are 4 hypersonic grid fins comprised of titanium that are positioned near the top of the first stage.
Stage 1, entry burn startup.
There's that call out. The entry burn has begun. This burn will last just about 15 seconds
Stage 1,
or
entry
so.
burn shutdown. One landing burn.
There's that call out. The landing burn has begun. You can see it there on your left-hand screen. Let's watch as Falcon 9 touches down.
Stage 1, landing leg deploy. Stage 1 landing confirmed.
And an awesome sight to see. As you can see, the Falcon 9 first stage that supported today's mission landed for its second time and has previously supported the Crew 7 mission in August earlier this year. This marks the 238th successful landing for an orbital class rocket. Now, next up in a few seconds, just about 20 seconds or so, will be the shutdown of the MVAC engine that you see ignited there on your screen. That event is called SECO, or Second Engine Cutoff, and that'll be the first shutdown of this MVAC engine.
SECO. Nominal orbit insertion.
Great news. We have just had SECO and heard a confirmation of good nominal insertion. At T plus 9 minutes into the mission, we are coming up on the last major task for Stage 2, commanding separation of Dragon, which is a couple minutes from now. We expect to have a live video of Dragon separation from the trunk looking back at Stage 2. CRS 29 will be joining the Crew 7 vehicle currently on orbit. So we'll be back to having 2 Dragon spacecraft docked at the International Space Station. As for cargo, today we will be delivering more than 6,500 pounds of science, research, crew supplies, and vehicle hardware to the orbiting laboratory and its crew. And to date, SpaceX has sent and brought back over 300,000 pounds of crew and cargo to and from the space station. Capsule. And another fun fact, once on station, Dragon can serve as an extra module for science payloads lacking room on the space station, which we refer to as Extend the Lab.
Dragon separation confirmed.
And there you can see on your screen, the Dragon spacecraft has separated from the Falcon 9 second stage. Now, if you're just now joining us, you're watching a live broadcast for the 29th commercial resupply mission to the International Space Station for NASA. This is SpaceX's 81st mission this year and 6th and final Dragon flight to station for 2023. We lifted off just about 12 and a half minutes ago from NASA Kennedy Space Center, Launch Complex 39A in Florida. And coming up in just a few moments will be the nose cone opening for the Dragon capsule. All right, so that will do it for me here in Hawthorne. So we are going to send it over to Chelsea in Houston to talk us through the nose cone opening. Chelsea?
Thank you, Jesse, and welcome back to the International Space Station's Flight Control Room. I'm here with continued live coverage here in Mission Control Houston. We got a view of launch up on the monitors here in the room, and just like you saw at home, the Cargo Dragon spacecraft is making its way to the space station as we speak. As Jesse explained, the spacecraft has already gone through a number of milestones. It separated from the second stage of the Falcon 9 rocket and performed a number of automatic checkouts, doing small firings of the Draco thrusters. The next major milestone that we'll be looking out for here in Mission Control is nose cone deploy. We already got confirmation that these latches, the things that are attaching the Dragon nose cone, are starting to come off. This is a process that's going to take a couple of minutes, and then that nose cone will begin to pop off. So let's talk a little bit about why we want this nose cone deployed. The nose cone protects the docking hardware that is needed to attach the Cargo Dragon spacecraft to the space station for its 1-month stay, so nose cone deploy is a critical step in our timeline today. The nose cone also unveils 4 forward bulkhead thrusters, which Dragon will use for its major burn maneuvers to catch up with the space station. There will be a checkout of these engines just minutes after nose cone deploy, and the nose cone also protects Cargo Dragon's navigational sensors during ascent. These rendezvous and tracking elements help the spacecraft understand where it is and where it needs to go to reach the space station. Now the nose cone is opening, and we're looking at the vacuum of space from the point of view of the Cargo Dragon spacecraft. Just because it's no longer on your screen does not mean it's fully open. It has a couple of degrees more to go before we get confirmation of good nose cone deploy. As a reminder, opening up this nose cone allows for access to the docking hardware underneath, critical for the Cargo Dragon spacecraft to attach itself to the space station. It also unveils the forward bulkhead Draco thrusters and navigational sensors that Dragon will help to understand its position in space and also make it find its way to the space station. We've temporarily lost our live views, but so you're looking at a live view of Mission Control Houston as we continue to monitor the nose cone deployment. And just like that, we just got confirmation that nose cone deployment is complete. This is a critical milestone for the Cargo Dragon spacecraft on its way to the International Space Station. Once again, we got confirmation that the Cargo Dragon nose cone has deployed. I do have a special guest joining me today. Joining me on the phone is Christy Depletion, Deputy Manager of the International Space Station Integration Office. Christy, are you with us?
I'm here. Thanks, Chelsea.
Christy, awesome launch today. I want to ask you a couple of questions about Dragon. So when it arrives, the crew schedule gets increasingly busy with science and research. Can you tell us some of the important work that they'll be doing?
Sure, that was a beautiful launch. Oh my gosh, and the booster landing was amazing. So the crew is very busy when it arrives. They're actually very busy even preparing for Dragon before it docks. The crew talks with payload developers to prepare for experiments they'll be doing. They also have a conference with our inventory and stowage officer to discuss the cargo being delivered and any changes to how they'll execute the unpacking and packing plan during the 30-day mission. The crew then does prepare for docking and ingress, and once Dragon is docked, the crew will perform their leak checks before they open the hatch. But yes, once Dragon arrives and the hatch is open, the crew gets right into work, and we'll begin working on some of the experiments that were launched. One of these that I find interesting is from the European Space Agency called cerebral aging. It's a study of the effect of spaceflight and durability in space on cerebral organoids. An organoid is an artificially grown mass of cells or tissue that resembles an organ, so in this case, the brain. The overall goal of this experiment is to study the aging process in cerebral organoids derived from normal individuals and those patients with accelerated aging that may or may not be displaying hypersensitivity to UV radiation conditions, similar to what living organisms are exposed to during spaceflight. So this experiment will help us learn more about the effects of space conditions on our brains as we prepare for even longer duration spaceflights. And of course, the crew will be busy unpacking Dragon, and they are always excited to get the fresh food. As you mentioned earlier, we have some holiday-type food the crew can enjoy, like turkey, cranberry sauce, cheeses, and chocolate. So I think they'll enjoy that a lot. A reward for their hard work.
Some science and some goodies. Sounds
Yeah.
awesome. So looking ahead, 1 month from now, Dragon has completed its mission. Can you share some of the hardware or research that Dragon is going to bring home back to Earth?
Yes, that's a great question. Our return missions are very important, just like launches are. They bring home research cargo as well as systems hardware that needs to be refurbished before we return it back to station. So the station is like our home and has equipment that needs repair and maintenance occasionally too. We are planning to return a few items on this flight for repair, including a resistive exercise device flywheel that provides the forces to simulate some 1G exercise for the crew. Another is a camera assembly that provides video feedback during our on-orbit robotic operations. And we're also returning the hardware that is part of the environmental control system for the plant habitat for repair. So this control unit keeps an eye on the humidity and other environmental factors within the plant habitat. So if you've seen pictures of tomatoes or peppers recently from station, they may have been growing in that facility. As far as the research over the next month, the crew will complete many, many experiments, and then a lot of that research will come home for the scientists to have in a pretty rapid timeline. So that allows them to get their results pretty quickly.
Christy, thank you so much for joining us here today.
Sure. Thanks for having me.
So back here in the International Space Station's flight control room, flight controllers are going to continue monitoring the next milestones of the cargo Dragon as it makes its way to the International Space Station. They're going to continue to look for some upcoming milestones going into Friday and then Saturday as the Dragon arrives into the vicinity of the space station, getting ready for docking. So that's it here from Mission Control. Back to Jasmine and Kennedy.
Thank you so much, Chelsea. That's going to wrap up our launch coverage of the 29th Commercial Resupply Services mission from both NASA and SpaceX to the International Space Station. As a reminder, docking is set for Saturday. That's November 11th at 5:20 a.m. and live coverage for that operation is scheduled at 3:45 a.m. Eastern. Thanks again for joining us tonight. We'll leave you with a replay of the beautiful launch. And until next time, go NASA, go SpaceX, and go CRS 29.